Welcome to the second part on friction. Now, I will advise you, if you are here to watch the first part of the friction aspect, then you should just check the channel and watch through the first part, because if you don't watch the first part, the second part here will not be much clear to you. Now, let's talk about, I stop at the questions under friction. Now, this will be the question number 5, because in the previous question we stop at question number 4. So question number 5 now. The question says calculate the magnitude of the force required to just move a 20 kg object along a horizontal surface if the coefficient of friction is 0.2. If the coefficient of friction is 0.2, this is the question. Solution. Now, since it is along horizontal, now we have the mass here. That's the mass is 20 kg. And don't forget, we'll be having the weight directed like this, and our weight is equal to mg, which will be 20 times. Now, since we are not given, you can use 10, that will be 200 Newton. Or you can still use 9.8 meter per second square, which is your acceleration due to gravity. Now, you have your normal reaction at the top. And the normal reaction that is at the top, don't forget, a normal reaction is the same thing as what? The weight. So which is 200 Newton, since it is on the horizontal surface. Now the question is, we are given the what? The frictional force, which is 0.2. Then we are asked to find the what? The force that will be required to move the what? The objects along the horizontal. Now the force that will be required to move, that would be the force that will overcome the static friction. And at the same time, that means the force will be the force, even the required force. Don't forget, I told you that the required force will be equal to what? The frictional force. Whenever you are dealing with the what? Whenever you are dealing with the horizontal component like this, the required force will be the same thing as what? The frictional force. Because once the required force is equal to the what? The frictional force, then that shows that the required force will be able to just, look at this, just move the what? The 20 kg. So once the required force is now greater than what? Than the frictional force, then it will move the what? The box easily. But here we can use the formula that says the frictional force is equal to the coefficient of frictional force multiplied by what? The normal reaction. So the frictional force is now, that's 200 multiplied by what? 0.2. So in which we have it to be 200 multiplied by 0.2, and that's 40. So we have this to be what? To be 40 Newton. And since Fr is equal to what? F. So since Fr is equal to F, that shows that the force that will be required to just move this object along the horizontal will also be what? Will also be 40 Newton. Now question number 6. Question number 6 says a metal box of weight 400 Newton is put on a horizontal rough surface with a force of 300 Newton. With the force of 300 Newton applied horizontally. Question number 1. Determine the coefficient of static friction if the force is just sufficient. The force is just sufficient to cause the box moving. Question number 2. Determine also the coefficient of kinetic friction if a force of 100 Newton can now keep the box moving with constant speed. We should determine also the coefficient of the what of the kinetic friction if the force of 100 Newton cannot keep the box moving. Now let us see to this. Now with this question, let's look at how we are going to resolve this question. Now see to this. The solution. The solution. The question says a metal of weight 400 Newton. That shows that the weight is 400 Newton. Don't forget, you have the weight at the below. Spool along horizontal. It is horizontal rough surface with the force of 300 Newton. Let's say the applied force here is 300 Newton horizontally. I told you it will be the same thing with the what? With the frictional force. And at the same time, your normal reaction will be equal to what? The weight. The first question says we should determine the what? The coefficient of the static friction just about just to cause the what? The box moving. Now the frictional force is equal to the coefficient of the static the frictional force of the static friction is equal to the coefficient of the static friction multiplied by the what? The normal reaction. And our FR will be what? Will be 300 Newton. I told you FR will be the same thing as what? As F. And at the same time, the normal reaction will be the same thing as what? As weight. If it is horizontal. But if it's not horizontal surface like this, if we are talking about inclined plane, then it's not the same. Then once you have something like this, then the frictional force, then multiplied by the normal reaction here is 400 Newton. So the coefficient of the static friction will now be 300 over 400 Newton. So if you get this, the answer is 300 over 400. You have it to be 0.75. So this is 0.75. That is the coefficient. 0.75. Now, the second question says, determine the coefficient of the static friction. We are asked to find the coefficient of the static friction if the force of 100 Newton, the force of 100 Newton is now to keep the box moving at the constant speed. So we have the force of 100 Newton to keep the box moving. So in which when you have this, don't forget that the F is equal to 100 Newton. Then we need our what? We need our normal reaction. And normal reaction here will also be what? 400 Newton. Because there's nothing different. It's still the same box that has the weight of what? Of 400. And our weight will be equal to what? Our normal reaction will be equal to the value of the what? Of the weight. So here, we have the same formula. The frictional force of the kinetic friction is equal to the coefficient of the kinetic friction multiplied by what? Normal reaction. The coefficient of the kinetic friction will now be the frictional force of the kinetic friction over normal reaction. And the frictional force of the kinetic friction here will be 100. Because of what? Because the Fr is equal to what? F. And we are given F. Then the normal reaction is what? Is 400 Newton. So the answer here is, when you have it to be 100 over 400. That's 0.25. So the answer is 0.25. Now this is the question. Now let's get to the next question. Question number 7 now. Question number 7. Question number 7 says that a 400 Newton crate rests on a ramp. Rests on a ramp. Rests on a ramp. The maximum angle just before it slips is 15 degrees, with the horizontal what is the coefficient of static friction between the crate and ramp surface? What is the kinetic friction between the crate and what? And the ramp surface? Solution. Now, when you have this, they said it has an angle, and the angle is 15. You have the angle to be 15 degrees. Let me restructure this. You have this. The angle here is 15 degrees. Now said the maximum angle of 15 degrees with the horizontal. Now said, what is the coefficient of the static friction? We are asked to find the coefficient of the static friction between the crate and the ramp. Now let's say this is a crate. They said the crate has 400. Don't forget, according to the resolution here, the normal reaction will be here. You have the weight here, and the weight you have here is the weight here is 400 Newton. But you have to resolve this weight into vertical and horizontal. Don't forget, the vertical will be W cos theta, which is W cos 15 degrees, and this side will be W sin theta. And since it is coming down, it slips. Since it slips, the frictional force will be in this angle, opposing the normal force that makes it to slips. Now you have your coefficients of friction. Don't forget, the frictional force of the static is equals to let me use the formula that says Fr is equals to the coefficient multiplied by what? The normal reaction. So the frictional force of the static will now be coefficient of the static multiplied by what? The normal reaction. Now the coefficient of the static will now be the frictional force of the static over what? Over normal reaction. Now if you check this very well, the frictional force of the static friction, I told you that the Fr here is equal to W sin theta here. So take note, this one will be equal to this, and this one will be equal to this. But unlike this one is equal to this one is equal to this. But this time around, this one is equal to this and this one is equal to this. So since Fi is equal to W sine theta, then here we now have it to be W sine theta over, then the N is equal to this. So don't forget. So this one is W sine theta. So N is equal to W cos theta. Take note. So this one will still be what? W cos theta. So W will now cancel W. Though we are given to be 400. If you include it, it will still cut each other. Then you now have it to be sin theta over cos theta. And the coefficient will now be sin theta over cos theta give us tan theta. Or you can do it straight up. But sin theta over cos theta give us tan theta. So this one will now be tan of 15 degree. So the coefficient of the static friction will now becomes, so we have tan 15 degree to be 0.27. 0.27. That is the coefficient of the what? Of the static friction here. Now the next question number 8. Question number 8 says, determine the magnitude of the minimum horizontal force required to maintain a box of weight 20 Newton when placed on a rough plane inclined at 30 degrees above the horizontal. And you are asked to take your coefficient of friction to be 0.2. You are asked to take the coefficient of friction to be 0.2. Now, when you have this type of question, it will be an inclined plane. So if you have this, let's draw the structure like this. This is a box. And this box, the normal reaction will be here. Normal reaction, the W will be here. But the theta is 30 degrees. Now once you have your 30 degree, we have to resolve this weight into W cos theta and W sin theta. When we resolve, since they said the box with a weight of 20 Newton, so the weight is 20 Newton, so W is 20 Newton. That's that this will be W cos 15. That will cos 30. That will be 20 cos 30. So this way will be 20 cos 30 because our W, and this way will be 20 sin 30. That's it. Now, don't forget that the frictional force will oppose this motion because they said determine the box, okay, when it is placed on the rough plane inclined like this, so it will slip down. But we are asked to calculate the force that will be used to what? To keep this. And the force that will be used to keep this box, that is, once it slips down, once it's going down, that is, there will be a natural force taking it down, which W sin theta. But the force for you to require to maintain the box, that is, to hold it, and that will be opposing the box because the box is coming to this direction. You have to apply that P to oppose this box. And don't forget, when I was explaining the formula the other time, when I told you that whenever there is a required force, then you should what? You should put it. It is either push or pull. It is either they push it in this direction or they push it in this direction. So it depends. But in this structure I drew for you the other time, I drew for you in the first case, there's no required force here. This is just enough. This is just the force that makes the box to slips, in which the frictional force will oppose it. It is inclined plane. So inclined plane, naturally the box will move. Unlike the case of unlike the case of the horizontal. If it is horizontal cannot just slip by itself. There will be a required force that will take it from the horizontal. That is why if you can see the structure of the horizontal here, the applied force is already here. But for this one, there is no applied force here. So this one is just the force, because it's on the inclined plane. It will move normally. But the force that will be required, because the question says the force that will be required to maintain the box. And that is why I told you, when you are asked to find the required force, then use P. Now when we use P like this, then the next process is that you have to resolve this into let's say the horizontal aspect of this, and let's see the vertical aspect of this. And don't forget the horizontal component of this, or let me do the vertical first. The vertical aspect is this. So that shows that for the vertical, our n here is equal to what is here, which is n is equal to w cos theta. So n is equal to our w is 20, so 20 cos what? Cos 30. That's the vertical. But if you get the horizontal here, horizontal is this and this are equal, but we have additional of the applied force here. So that means if you now check this very well, you will observe that both the applied force and the frictional force are facing the same thing, because it's just to hold it. So that means the applied force to hold it, to maintain the box, will be supporting the frictional force, because frictional force opposes this normal one that is taking it to slips. But the frictional force and the applied force to hold it, assuming they said the force to make it slip more, then we have to calculate this. We have to add it to this one. But it is we want to maintain it. I'm still bringing another question that will be similar to this. Now, so it's just to hold it. This one and this one are facing the same direction. So this one, W sin theta, will be equal to the frictional force plus plus P, because frictional force and P are facing the same direction. Now, when you have this, you will now observe that your W, which is 20, then sin 30 is equal to your frictional force is, don't forget that frictional force is equal to the coefficient of frictional force multiplied by what? N. Since we are not given the frictional force, but we are given the we are given the coefficient of friction, then plus P. Don't forget it is P that we are looking for. Then if you check this, you will observe that we have N the subject of formula here. And let's try and make N the subject of formula here. So 20 sin 30 minus P will now be equal to the coefficient of friction multiplied by N. So N will be equal to 20 sin 30 minus P all over what? All over the coefficient of friction. So now, since N is equal to this, N is equal to this, N is equal to this, if this one is equation 1 and this one is equation 2, we can select equation 1 be equal to equation 2. So we have 20 cos 30 will now be equal to 20 sin 30 minus P all over the coefficient of friction. So what is 20 cos 30 will give us 17.32. 17.32 equals to, now this time around we have 20 sin 30. That will give us 10. So we have 10 minus P all over the coefficient of friction is given to us, which is 0.2. Then if you cross multiply, we have 0.2 into brackets 17.32 to be equal to 10 minus P. What is 0.2? 0.2 multiplied by 17.32. So the answer is 0.2 multiplied by 3.32. The answer is 3.464 to be equal to 10 minus p. Now let's make p the solvent formula. If you take minus p to this side, it becomes p to be equal to 10. If you take the 3.464 to the other side, that's 3.464, then the answer will be 10 minus 3.464. The answer will be 6.5 Newton, approximately 7 Newton. So that's the answer. 6.536 Newton. Approximately 7 Newton. Now the next question, that should be question number 9. What's question number 9? Question number 9 says, I'll just use this question number 9 to back up the previous question, like the one we just solved now. It says a horizontal force of 45 Newton applied to a crate of mass 9 kg is just sufficient to move it. It's just sufficient to move it. If the crate is now put at an angle of 50 degrees to the horizontal, find the required force to move the crate over the horizontal surface. We have to take G to be 10 meters per second square. We have to take G to be 10 meters per second square. Now, how are we going to do this? You will observe that the first thing is this. Solution. They said the horizontal force of this is a crate. The horizontal force is 45 Newton applied to this crate of mass. The mass of the crate is 9 kg. So that means there will be weight. And weight is mg, which will be 9. They said we should take G to be 10. So that's equal to what? 90 Newton. And we have N as well. Since N is equal to W according to normal horizontal like this, so it will be equal to what? 90 Newton as well. Normal reaction will be 90 Newton. And there will be frictional force that will oppose this. And don't forget, for this reaction, frictional force is still what? Normal force. So the frictional force will also be what? Frictional force is the applied force, is equal to applied force in this case. Frictional force is equal to applied force in this case. So it will also be what? 45 Newton. Now we are asked to find the what? They said if the crate is now okay, we have not gotten to this second statement. We are still at the first statement. In the first statement, we will have the frictional force to be coefficient of friction multiplied by what? Normal reaction. So the coefficient of friction will now be Fr over N. And our Fr is 45 over N, which is 90. So the answer is now, that's 45 over 90. So the answer is 0.5. So we have this to be 0.5. So that means we've gotten the coefficient of friction. Or let me even say the coefficient of the static friction, because it is at the what? At the same point. But the second statement proceeds by saying, okay, this same mass of 9 kg is now pulled at an angle. So it is pulled at an angle. Let's say this is the angle. It is pulled at an angle of 50 degrees. So that means there's a force applied, and let's take that as what? As P. The force applied, as we did in the previous one, I told you whenever you are using the force applied, use what? You use P. Now if this is a P, the force applied is P. And don't forget, this is when pull. It is pull like this. So it is let's say they drag it. Now this pull now, it has an angle of what? Of 45 degree. Now when it is pull at an angle of 45 degree, they say to the horizontal, find the required force, and that's P. The required force we want to find is P. But don't forget, there will be frictional force that will oppose this motion. Because it is pulled like this, the frictional force will oppose. The weight of the object will still remain the same, which is mg, and that's 9 times 10, which is still equals to what? 90 Newton. And don't forget, the normal reaction will also be there. The only thing that will change is that the frictional force will not be equal to the applied force again, because the applied force is now the applied force now have what? Now have angle. So it's not like the horizontal applied force we have before, but the applied force now have what? It's now have what? An angle. So we have to resolve this applied force into vertical and horizontal. So in horizontal like this is the side that has the what? That has the theta. So it will be P cos theta, and this side will be P sin theta. So this one, which will be P cos 50 degree, and this side will be P sin 50 degree. So if you check this around, so we have to resolve this into horizontal, and we have to resolve into what? Into vertical, like the way we did for the previous one. And let's say the horizontal aspect, this is the horizontal one, horizontal, this is also an horizontal aspect. So if you check it, this we just have only two horizontal, so in which the FR will be equal to P cos 50 degree. That is the horizontal. We just have two, but the vertical this time around now becomes 2, and now becomes 3, because we have this to be vertical, we have this to be vertical, we also have this to be vertical. But assuming we just have it to just be only one, we just say N is equal to what? W. But here it can never be equal, so we will be having it to be the weight. The weight, which is W, is equal to N, that is here, plus the other one, which is P sin theta. Now you can see that the same way we resolve this one, the F, R and P, they are facing the same thing. P is going to this direction, the frictional force is also going to this direction. That's why we sum these ones going to this direction to be equal to what? The other one. That's why we have it to be horizontal here. And at the same time, this one as well, this one and this one are facing the same direction. That's P sin theta and the N are facing the same direction, so to be equal to what? The other one that is facing the opposite direction. Now let's proceed. The FR here, don't forget that FR is equal to what? FR is equal to mu multiplied by what? The normal reaction. So we have the coefficient of the friction multiplied by normal reaction to be equal to P cos 50 degree. And here we have the weight. We have the value for the weight already, and weight is 90. So because we don't know the normal reaction this time around because they are not equal to the weight. Then plus P sine, and our theta is what? Is 50 degree. Now if we check this, we have the value for the coefficient of friction, and that will be 0.5. Sorry. That will be 0.5. The coefficient of friction is 0.5. The coefficient of friction is 0.5, so multiply by N is equals to P cos 50. So we are looking for P, that's the required force. So we have to do it in such a way that it will be equal. Then let's make N the Soviet formula here, N the Soviet formula here, so that it can cut each other. But when you check this, we have N to be equals to P cos 50 degree over what? Over 0.5. Then here, let's try and make N the Soviet formula here as well. We want to make N the Soviet formula here, we can have it to be 90 minus, if you take this one, it will become minus P sin 50 to be equal to what? N. So we have N as the subject of the formula because n will be equal to 90 minus p sine 50 degree. So n is 90 minus p sine 50 according to vertical, but here according to horizontal, n is equal to p cos 50 over 0.5. Now when we proceed with the solution, then let's equate. If this one is equation 1 and this one is equation 2, let's equate equation 1 to be equal to equation 2. So we have p cos 50 over 0.5 to be equal to 90 minus p sine 50. Now the next thing is to generate how you are going to find p or make p the subject of the words of the formula. Then what are we going to do? Let's cross multiply. We have p cos 50 to be equal to 0.5 into bracket 90 minus p sine 50. What's cos 50? Cos 50 is 0.64. So we have 0.643. Let's approximate to be 0.643. So 0.643p will now be equal to, let's use 0.5 to multiply the bracket. 0.5 multiplied by 90. If you use it to multiply this, so 0.5 multiplied by 90 will be 45 minus 0.5 multiplied by the other one. So that will be 0.5 multiplied by, so we can only multiply by sine 50 here. So multiply by sine 50 will give us 0.383. So we have this to be 0.383p. Then let's take this one to the other side here. That will be 0.643p. If this one comes here, it becomes plus 0.383p to be equal to 45. So let us add this together. 0.643 plus 0.383. That gives us 1.026. 1.026p to be equal to 45. So p will now be 45 over 1.026. So we have 45 divided by 1.026. So the answer is 43.86 Newton. Approximately 44 Newton. That's the required force. 44 Newton. So let's see